Right, sum and product of roots. So we have 2 more questions to do from last lesson. So, B. Form the quadratic equation, which roots are -1.5 and 4. They're the 2 roots of your quadratic equation. A couple ways we can do this. Okay, Kyle and Robin will probably be able to tell me both ways straight away.
There's the thing.
They are the 2 roots. So remember what we did in an earlier lesson in a different course.
Which course? Extension 1?
2.
No, yes, maybe. Jump that.
Okay. Alright, so this comes from x equals -1.5 and x equals 4. What was the step before that?
X. There's the thing.
The thing.
Quadratic formula.
The thing. Yes, I'll totally give you full marks for your exam.
The thing.
By using the thing, I have derived the x equals.
Maybe you should do that presentation.
The thing. Just from the roll.
Alright, so x plus 1.5,
Oh,
x
seriously?
take away 4 is 0.
That was hard.
So difficult. Okay, you got to take the extension 2 stuff out of your mind and think just more straightforward in this course, because it is going to be very straightforward compared to what you're doing. Okay, so what I've done is you've been told the 2 roots, okay? So from that, if you think about working through your quadratic formula or factorising, when you factorise, you have this form, and then from that you'll tell me x equals -0.5 and x equals 4. They're going backwards, alright, really, to this question. What do I do next? Expand. Okay, so before I expand, the x, I'm going to write that as an improper. So 1 times 2 plus 1. Of course, remember that how to do that from year 7. Okay, just makes it easy on the expansion. Okay, that's all the reason I've done it. Okay, expand it using your FOIL. So x squared outside -4x plus 3 over 2x, take away 3 times 4, which is 12, 12 divided by 2. Okay, using your FOIL. Get squared. Okay, so minus 8x over 2 plus 3x over 2, take away 6. Now, what I've done here is I made the -4 as a -8 over -2, so that I can do the addition of the 2 x terms there. So, x squared, so -5 over 2x, take away 6 is 0. Yeah, and that's a acceptable answer for your quadratic that those 2 roots will come from. So if you went through and did the quadratic formula, that's your 2 solution. Okay. Now, the alternate way we can have that answer, because of the fraction, okay, I can multiply everything by 2. So I get 2x squared, take away 5x, take away 12 is equal to 0. Okay, so this is an acceptable answer. This is just an answer without fraction. Okay, by multiplying everything by the same number, still get an equivalent equation. Okay, so that's our quadratic equation. But of course, that doesn't match our sum and products. This is under the heading 4. So, what do I do under the context of sum and products of roots?
See, hey, test it. try the sum of two at a time and then test it without.
Okay, remember, what is the sum? So let roots be alpha and beta, which is already told for us.
Is it, do you go one at a time and then two at a time and then you simultaneously?
You don't even go that far.
No?
Yes, some one at a time, some two at a time, yes. Okay, so what is alpha plus beta? Yeah, okay, which equals, so alpha, so let roots be alpha, which equals -1.5, and beta, which is equal to 4. So, oh, really, I'll probably write it in proper, just make the math easier. -3/2. Okay, so sum of the roots, -3/2 plus 4, the -3/2 plus 8/2, which is 5/2. When you work it out. And the sum of the roots one at a time is equal to -b/a.
Oh, you should do that, hey?
Alright, product of the roots, or sum two at a time, and this is only as far as you need to go for this section because we're only working on quadratic equations. You need to be doing extension to go further. And extension 2 to go even further. Alright. Now, product of the roots. So, -3/2 times 4. So -12/2. Which equals -6. Hey?
Doesn't making it 6 make it a bit more complicated though?
Yes. Yep, it will. Okay. Very good. So we'll go back to this step. What is the product of the root? C/A. And yes, Michaela has correctly observed that the value of A needs to be the same. Alright, so I didn't actually need to go this far, okay, unless I simplify this down. Okay, so 5 on 2 is equal to -b on A. Okay, so 2 equals A, 2 equals A, 5 equals -b, so B equals -5, and C is -12. So, from that, from equivalency, A is 2, B, so -b is 5, so B is -5, and C is -12. Y equals ax squared plus bx plus c. Y equals 2 x squared, take away 5x, take away 12. Look at that. Exactly the same answer.
Whoa. Whoa, man, that was gnarly.
Okay, so there's an alternate couple of ways you can do it. So that was question in the exam, you can do it either way, but because under the heading of sum and the product of roots, okay, I better show you how to do it using sum and product of roots. Any question? And we now have a part C, quadratic equation. Right, C. B, quadratic equation. So I've got 2x squared, take away m plus 2 of x, plus m equals 0, has one root which is twice the other. Okay, one root, which is twice the other. We need to find the value of m and hence write down the quadratic equation it represents. Okay, so one root is double the other. So how am I going to answer this question?
2 alpha equals beta.
So,
2 alpha equals beta.
2
I can do that.
equals alpha. No, no. Set the roots 2 alpha and alpha.
So we set the root to match the condition. So if one root is double the other, we have two roots because we've got a quadratic. So normally we'd let the roots be alpha and beta. Okay, but we are told that one root is double the other. So let root be alpha. So set your first root and then set that second root to match this condition. Double the other, 2 alpha. Okay, so roots one at a time, you negative b on a. So you've got alpha plus 2 alpha equals negative b, which is a negative m plus 2 over 2. Okay, so tidy this up as far as we can go. So 3 alpha is equal to m plus 2 over 2. 6 alpha is m plus 2. Okay, so bringing this up to the other side and multiplying. Alright, sum of the roots 2 at a time. So it's not saying our roots alpha and beta, it's just notation to say that we're summing the roots 2 at a time, and when we have a quadratic, it is the only 2 roots. Okay, which equals c on a. We've got to establish that in your question. So that means the product of these 2 roots, alpha times 2 alpha, is equal to c, which is m over 2. So 2 alpha squared is equal to m on 2. Okay, so what am I trying to do though? Find the value of m. Okay, so we have 2 variables, we have alpha and m. However, we only really need to solve for m. We don't actually need to solve for alpha in there because we're not interested in alpha really. We're just interested in value for m that completes this quadratic here. So what I'm going to do? Alright, so I'm going to go 4 alpha squared is equal to m. And I'm going to go alpha is equal to m plus 2 on 6. Okay, one way you can do it, not the only way we can do it. Okay, so let's call this 1 and that 2. Okay, so I'm going to substitute equation 1 into equation 2. So every time there's an alpha in equation 2, I'm going to replace it with m plus 2 over 6 in equation 1. So 4 alpha squared, so 4 of m plus 2 over 6, or squared, equals m. Okay, so we replace alpha with what alpha equals in this first equation, so that I can get a solution for m. Okay, it's not the only way you can do it. You can set it up differently, but we'll get the same answer if the math is correct. Okay, so 4m plus 2 all squared over 6 squared is equal to m. Okay, using index clause, so that's squared and that's squared. So 4 over 36 m squared plus 4m plus 4 is equal to m. So we've expanded that. 6 squared becomes 36. Okay, cancel 4 and 36. So we've got m squared plus 4m plus 4 is equal to 9m. So move that over to the other side. Okay, so now I'm going to have another quadratic to solve. Okay, bring the 9m over to the left-hand side, but performing the opposite operation, get everything equal 0, and we have a quadratic to solve. Right, so m take away 4, m take away 1 is 0. So m equals 4 and m equals 1. Okay, so two numbers multiply to give positive 4, same two numbers add to give negative 5. The negative 4 and, m take negative 4 and negative 1 gives the product and the sum. So m equals 4 and m equals 1. Right, we're done? Trick question, isn't it? What do I need to do now? So? We don't need to. Well, yeah. However, it's probably a good idea that we do check. Okay, so let's put these two in equation 1 and check that it matches equation 2. Because if it doesn't suit both equations, then it can't be a solution for the question. Right, so alpha is going to be m plus 2, so 4 plus 2 over 6, which is 1, when m equals 4, and when m equals 1, we have alpha equals 1 plus 2 over 6, substituting into here, which equals a half, and verify that it matches this one. Alright, so 4 alpha squared must equal m. So alpha is 1, m is 4. So 4 times 1 squared, which is 4, which is m. That works. And m equals 1, alpha will become a half. Okay, so a half squared is what? A quarter. 4 times a quarter is 1. Okay, so yes, they both work. Probably a good idea that we do check that. Right. So that means we have two quadratic equations that we can represent that has one root double the other. Right, so the original quadratic was 2x squared, take away m plus 2 of x plus m equals 0. So quadratic 1, we can have 2x squared, so m is 4. Take away 4 plus 2, which is 6. 6x plus 4 equals 0 is a valid solution. And when m, so this is when m equals 4, and 2 when m equals 1. So we have 2x squared, take away 3x plus 1, 0. Okay, so you need to write down both those to get your full marks. Okay, or if you can identify a value for m that doesn't work because it doesn't match both the equations that we had set up simultaneous, then you'll need to write down only the one, but you'll have to show the verification why you're not writing up another one for another possible value for m. Question? 140. I'm not going to have time to get through, so I'll finish that up tomorrow. And then the rest of tomorrow will be working lesson, and Friday